Okay, so my name's Rob Holt. I'm an engineer on the PowerShell team, and I want to talk to you today about using what I'm calling the PowerShell API for the purposes of this talk. So, what we're going to talk about. Well, first of all, I want to define what I really mean by the PowerShell API, and I want to motivate it a little bit. I want to tell you why it's worth knowing about and when you probably want to use it. Then I'm going to show you, okay, how do we use it to just sort of run ordinary PowerShell, basic invocations. Take a look at manipulating outputs and inputs from commands, invocations that we run. Take a look at composing these invocations into more complex things like pipelines and statements as well, actually. And then we'll look at using the API with more sophisticated tooling like configuring your own run spaces, running it across different threads, using it asynchronously. So what I'm using this term PowerShell API. What do I actually mean by this? Normally when people say PowerShell API, they're referring to everything that the PowerShell SDK exposes, and that I think is probably the right terminology to use. But within PowerShell, there is a type called PowerShell, and it provides a sort of API to construct and run PowerShell commands. And I'm referring to that when I say in this talk, PowerShell API. I don't really know what else to call it, to be perfectly honest with you. I guess I could call it the PowerShell type or the PowerShell object, but really I'm interested in its properties as an API. And so I'm calling it, that's what I mean by the PowerShell API. It looks like this. You create a PowerShell object, you add a script to it, and then you invoke it. Something along those lines, right? It's very simple to use, at least at first. But as you start building more functionality around it, you realize that there's a lot that it can do. It has a lot of bells and whistles and knobs to twiddle, and you get quite a lot of configurability with it, and it can do a lot for you without really you having to work all that hard, to be honest. It's usually the API that you're going to want to use in most cases, or at least in a lot of cases, when you are running PowerShell from .NET. So, like, when is that? Why do you want to know about this API? Well, usually when you're running PowerShell from .NET, you're running commandlets. And there are other ways to run PowerShell script from commandlets, such as the invoke command API and even just script block.invoke. And they can be quite useful, and in the context of commandlets, sometimes you should prefer them. But when you want to do something more structured or more intricate or more complicated, then running using the PowerShell API is going to give you a lot more configurability, and it's possible to use the PowerShell API pretty much anywhere where you would use one of the other APIs. Another example I see a lot is when people are writing .NET code that isn't implementing a commandlet, but is designed to be part of a wider PowerShell module, or is going to be invoked in some way from PowerShell indirectly, and they want to run PowerShell sort of deep within their program. Well, one straightforward way to do that, the easiest way to do that generally is to use the PowerShell API. It's not always necessarily the right thing to do, but it's often, and it's an important sort of tool to having it built. Any standalone executable that you write in .NET that you want to bring PowerShell along with it, that you compile with the PowerShell SDK, that you want to run PowerShell, the primary way, really the only way that you should be running PowerShell from a program like that is through the PowerShell API. And as an extension to that, if you ever find yourself implementing a PowerShell host where you define a class that extends the PS host type, So for examples of this are the PowerShell executable, the integrated console in VS Code, the ISE are all PowerShell hosts, and host in sort of like as a proper noun, what PowerShell refers to as a host. You're almost certainly going to want to use the PowerShell API to accomplish that. I also think it's just useful to know about the PowerShell API because if you're a PowerShell developer, you know how to call .NET from PowerShell very easily, and it's worth knowing about how to call PowerShell from .NET. It's worth understanding, all of the concepts at work there, and also gives you some insights into things like how PowerShell does it itself. So at this point, we're going to just jump right into the code, I think, because really this is a talk about how to use an API, and the best way to demonstrate that is by showing you directly how to do it. So first of all, when you use the PowerShell API, you have to create a PowerShell object. And it's pretty straightforward. You take this PowerShell type. You can't use it doesn't have a public constructor because there's more involved to set up, but this PowerShell.create is quite well known and relatively well documented. And you get an object back, and it's of type PowerShell. And something that's important to do here is to make sure you dispose it, in this case using a using block, because often this will create resources required to run PowerShell. If you don't dispose it, then those resources go and register themselves somewhere, and you'll start leaking things. And if your application is supposed to run for a long time or doesn't shut down immediately after invoking PowerShell, then that's probably a bad thing. So you need to make sure that you are cleaning up after yourself properly. So the basic example of running PowerShell using the PowerShell API looks like this. We say, something like get child item path dot, which is rather artificial example, but it's useful for our purposes. And then we invoke it and collect the results. So we say PowerShell dot invoke, and then because we're just trying to demonstrate that this sort of works without doing anything particularly useful here, we're just going to print out the results as we get them. So when we run this program, yes, I have saved it, good, we get the contents of the current directory. And so this is quite interesting already in a number of ways. One, get child item is using a relative path, and that implies some kind of state of PowerShell, which is its current location. And you'll notice that its current location is this PS API folder, and that's exactly where I am. And so, whether or not you intend to use it, PowerShell has a concept of its own state, and it's important to be mindful of that. Ideally, you shouldn't be running any commands that depend on that state too heavily, or if they do, you should be managing that state very carefully. But it's worth bearing in mind that that this sort of does play into things, and without you really thinking too hard about it too. The other thing to note is that, like, if we just run get child item ourselves, we get very different looking output to this. And that's because when PowerShell does this, it runs the formatter on the output. Whereas for us, we're simply getting a wrapped result. We're getting a file system info object back from get child item wrapped in a PS object. And when we call writeLine on result, it simply calls toString on that, which calls toString on the underlying object. And we can sort of prove this by showing that if you do the same thing with PowerShell, explicitly, you get exactly the same output. Okay, so we have sort of like you could get away with writing programs like this, for a while, I'm sure, but there are a bunch of things that we can improve here. The first thing is sort of a stylistic one, but it's that the PowerShell API is a fluent API. So you can chain its invocations like this, and often people chain invocations down like that. I find that quite readable, to sort of build the state before your invocation. That means that all of you don't have to redeclare PowerShell all the time with, you know, semicolon, semicolon, semicolon. You just put it all into one sort of bundle and then ship it off. And it doesn't always, you know, as we get more complicated, we'll see that doesn't always bear out, but, you know, this works, you know, exactly the same way as we expect. Another sort of what initially seems to be a style note is that this add script phenomenon is kind of a pain, because we've just given it a raw string to execute, which, you know, in general, executing strings as programs inside your program isn't really a good idea. It can be unsafe if you're taking user input. It can be, it's hard to analyze. You know, you can hide all kinds of evil inside a string, right? Instead, I don't know what that, but instead, you can do something like this, where we add the command and the parameter as separate pieces into a more structured API. So instead of using add script, add command takes the name. It says command, well, that's misleading. It takes the command to invoke, much like in PowerShell, if you did this, say. So where get child item is really a string passed to PowerShell's invocation syntax. That means that you can't just put arbitrary script in here. It must be the name of a command. This also supports native commands, and it supports paths to scripts on the file system. But you can see that when we run it, again, we very excitingly get exactly the same result we got the last few times. But this is good, confirms that, you know, we are able to restate our program in a more structured way. But in fact, that's not the main virtue of using this add command, add parameter methodology. The real advantage is when you have something that, when you have a commandlet that takes a real runtime type. So convert to JSON is a great example where if we had to write it in a script, then whatever we were converting to JSON, well, we already had to convert it to a string just to convert it to JSON, and that's really unhelpful. But what if instead, I mean, we're writing this from a .NET program. There's a reason we have PowerShell hosted in our process. We're trying, you know, PowerShell is an object-oriented shell. We want to be able to pass objects to it. So what happens if we have a hash table where we really do, you know, have an object and we want to pass it to PowerShell? Well, we can do something quite straightforward there, which is that if you look at the API for add parameter, you can see that its value is an arbitrary object type. So in fact, we can pass through our full .NET runtime object straight through to PowerShell. And we can see that, yes, we really do get the output that we expect. Another interesting point here is that you might have noticed that there are actually two overloads for add parameter. So we can add a second parameter, for example, with get child item, and see this parameter doesn't take a value. Well, what's a parameter that doesn't take a value in PowerShell? It's switch. So if we say add command get child item add parameter path dot add parameter recurse, it's going to be the same as simply providing this switch parameter recurse. And again, if we run the program, we can see that we get lots and lots of values this time because we recursively enumerated our current location. So that sort of covers, you know, how to manipulate parameters. What about the output that we're getting? Well, let's look at a slightly sort of more output-oriented command, like get date. In this case, well, let's look at the help for get date. we see that getDate as a commandlet takes this date parameter, but that date parameter should be of type datetime. And previously, when we used convert to JSON and things, we were able to provide a fully instantiated object to convert. And indeed, with datetime, we can say, okay, well, let's create a datetime object, oops, and add 10 hours, say, so that when we run our program, it gives us the date for 10 a.m. today. Okay, well, that's nice, but if you were in PowerShell, you wouldn't write datetime today at hours 10. You would write a string that much more succinctly expressed that date. For example, providing just this sort of 10 a.m. string will have the same effect. And when we run our program, we can see that this actually does work. And the reason for that is because PowerShell provides the usual parameter binding logic that it always would. Just like in PowerShell itself, when you run getDate, date at, I mean, the PowerShell formatting applies, but it's able to convert a string to a datetime value. And it's able to do the same thing in this circumstance too, because it runs the type conversion logic on inputs that you supply. Now, in .NET, that's probably not always desirable. You probably should be constructing strongly typed inputs to a commandlet that you're using. But it's worth knowing that this does happen because it means that your inputs might be converted by PowerShell if they don't match the parameter type. Another nice thing about getDate is that we know, especially with this invocation, what type it puts out. It creates a datetime object. So we can actually specify that with the PowerShell API by saying that by using this generic overload of PowerShell's invoke method to say, okay, I expect datetime back. And when we do this, we have to be ready to receive a collection of datetime objects. And then all we have to do is print those. When we run the program again, we'll see, well, exactly the same output, but what's interesting is that we can now do things like manipulate that output directly, right? Because it's now the ordinary .NET type that we would have gotten back if we'd called a .NET API. So we can manipulate it just the same as ever. This is really handy, but you might get the type wrong. What happens if we get the type wrong? Well, let's find out. Turns out we, surprisingly enough, get a big error and it says, okay, well, can't convert this value datetime to this value int because it's an invalid cast. You can see that we're using the language primitives API. And so that suggests that, in fact, PowerShell, just like it converts parameter values, can also convert outputs. So let's. And indeed, even though getDate produces a datetime value, because PowerShell knows how to convert datetime value to a string value, when we specify that we want string as output, and because it's possible within PowerShell, we get a string back. You can really see the difference in this particular scenario because we're running as a sub-process, so you always get a string back. I can't prove it to you in the command line. So this is really nice in the case of a commandlet like getDate, where we know what type it's going to return. And for a particular invocation, you might always know that. But some commandlets return different types based on the way in which you invoke them, and some of them don't return an ordinary .NET type at all. So, for example, let's look at convert from JSON. Convert from JSON takes a string and it gives us back a PS custom object. So, for example, let's just make a really simple JSON object, which has this key X and this value 1. When we run convert from JSON, we're going to get back a PS custom object. How do we deal with that in PowerShell? Well, the answer's kind of staring us in the face, but let's watch what happens. So when we run this, we get back some object, which we currently represent as PS object, and it gives us this, actually reasonable representation of a PS object. The truth is that PS object is perfectly capable of wrapping and describing these types. If we want to do something like get at the value of the property X, then all we have to do is use the PSObject API to do so. Underneath, this is a PS custom object, and you can use that instead if you prefer, but you can unwrap it using the base object property on the PS object, but it'll behave approximately like this does. One thing you might find convenient, though, is instead casting this to a .NET dynamic type, so that you can directly reference this just like you would in PowerShell. So if we did something like, if we had this as a PowerShell variable, we'd be able to say, object.x. Well, using dynamic in .NET, we can do exactly the same thing. This is because PowerShell's PS object implements special GUI under the hood, which allows dynamic to sort of hook in to its property accesses and things. This isn't really what I'd recommend for something like convert from JSON, because the input isn't well defined. It can change, and so your properties will change a lot. Depending on what you have, you might want to programmatically change the property access, and that's not really what dynamic is for. What it's much more useful with is something like invoke script analyzer, where the module itself defines strongly typed .NET objects. So if we look at the output of script analyzer, you can see that the output is a real .NET type, and it comes from the script analyzer assembly. The problem is that from our program, we can't reference that statically. So there's no value we can put in here that will compile to say, yes, I'm looking for a diagnostic record like script analyzer outputs. But instead, if we look at something like x.message, we can see the message of X. Script analyzer defines a formatter, so we have this sort of nicely formatted output. But if we wanted to manipulate a record like this without too much fuss, and we know that it's from invoke script analyzer, so we know what properties are defined on it, then we can simply use this dynamic cast to reference those methods directly. So those properties directly. So you get sort of quite a nice result like that without having to do too much work in your own code. Okay, so we have a fairly good understanding of parameters, or at least so we think. I want to talk a little bit more about when you use scripts directly with the PowerShell API. So, for example, let's come up with a really silly script that just takes an argument and adds 3 to it, say. Is that going to be useful to us here? Well, the answer is yes. And so the first thing to note is that when you use add script, all of the normal default or automatic variables are populated. And for arguments, you can add them simply by using the .add argument. So we can say, okay, add 5, and let's convert this back to an ordinary PS object and run our program again. And we get 8, which is 5 plus 3. So it works as we expect. We can actually also define it as a parameter. So we can say $p, p plus 3. We can say add parameter p, and we're going to set P this time to say 4. You can see that this script, works just like an ordinary PowerShell script where we have a param block at the start and we have a body. And when we run it this time, we'll see that we could set the parameter P plus 3, P is 4, so P plus 3 is 7, and indeed we get 7 exactly as we described. Is this particularly useful or interesting? Not really in and of itself, but it starts to get more interesting when you do something like, look at what else is defined, say the input variable. So input is the automatic variable for pipeline input, right? So when you pipe to a script that in a script block, say, the input variable contains everything that was piped to that script so far. And in order to specify the input with the PowerShell API, we want, you can see there are actually multiple overloads of invoke, and input is common to many of them. So let's provide that input here. 1, 2, 3. So now we're going to take every input to this script and then add 2 to it. Okay, so now we've got 3, 4, 5, which is exactly what we expected. And this is quite interesting on a couple of fronts. One is that, our input was populated properly and we added everything. So this has just sort of worked magically. But another interesting thing is that we realize now why we always get a collection of PS object. PowerShell is about enumeration and pipelines, and any script that you invoke could return 0 or more results. And so, you're not like PowerShell never guarantees that you get exactly 1 or exactly n results. You're always, by default, the PowerShell invocation is always going to return some collection. So this is, interesting, but it's a little bit cumbersome, and it still suffers from the same issue that we had at the start, which is that defining things in script, referencing PowerShell variables in a string, isn't really ideal. Instead, we'd really like to be able to define a pipeline using the PowerShell API, and so that ideally we could just take what we have here and then implement it in a more structured way. Well, that's also actually very easy to do. So we can just take our for each object command, and we can use add argument. So add argument works for commands of any kind, and when used with the commandlet, it simply sets a positional argument. For each object's positional argument here is a script block, and we want it to add 3 to everything that it sees. So whereas we previously used $inputs for our script, what's actually happening here is that we're defining that $input is implicit at the start of the pipeline we create with the PowerShell API and sent in through this input parameter to invoke, and then sent through for each object. That is to say, when you provide an input, the rest of your structured command becomes a sort of pipeline definition. So we're now running something like this pipeline. Let's have a look. So you can see, we're adding 3 to each thing, and we started 1, 2, 3, and we get 4, 5, 6. So that's exactly what we expect. But what if we wanted to add more things to our pipeline? What if we wanted to do something like where object, okay, so we're getting 4, 5, 6. What if we want greater than 4? Well, all we have to do is call add command again. And this time, let's, for the sake of a good example, add it as a named parameter instead. So on where object, this script block is named filter script, and we have to call script block again, and instead we'll say greater than 4. And so now we're expecting to only get 5 and 6 back. And indeed, that's exactly what we get. Now, what you might notice about this is that we're defining this sort of pipeline using this fluent API, and that's quite nice. It's also reminiscent of .NET's own link. One thing that link is good at is carrying the types through, and with PowerShell we can do the same kind of thing. We also have to make sure that it's an enumerable. So we can use select, and we can also use where. Okay, so we're multiplying by 2, we got 5 and 6. Let's demonstrate that we're actually doing things again. I more than 10. So this time we're only expecting 12 back. Indeed, that's exactly what we get. And one thing where link is really convenient here is if you only want one result back, you can simply say, use link to say first. So that now, when we run the API, run our invocation, we don't have to use a for each loop to do anything. We just use link's nice integration with this sort of collection output to get exactly the result we expected. This is really nice when you only expect one result. And you know, it's interesting that that link and PowerShell both have this sort of pipeline, you know, fluent API concept at work. That's no coincidence. They are both implementations of a sort of enumeration pattern, and I personally find that you know, obviously I've used for each object and where object here. They map perfectly to select and where. You often don't have much reason to use specifically these two commandlets in PowerShell from .NET, but it's often really useful if you call you know, a big commandlet invocation and then use link to sift through it later. So you sort of get out of PowerShell as soon as you can. The other thing that you can do with the PowerShell API, let's just convert some of this back here. The other thing you can do with the PowerShell API, remove this input, is actually compose statements with it. So for example, we can say something like x equals 2. That's not going to give us any output, but the PowerShell API has one more method, the add statement method, which allows us to effectively put a semicolon in the middle of our PowerShell program. And then we can add another script which references x, and effectively is like setting x and then in the next line referencing it. So when we run this, we'll see that we set x to 2, and then yes, we actually do get 2 back as a result. One thing that's interesting to note here is that add script has a parameter called use local scope, and by default that's false, and that means that by default add script dot sources the script that you give it and defines it globally. Defines it into the sort of higher level context. If we use set use local scope to true and we run our script again, we'll find that we get no output, or we get a null output, because when we use local scope, x is only defined within this script. So once that's done, you know, after this statement, we don't get any output back again. So I want to talk a bit more about this PowerShell create part of what we're doing here. Let's simplify the actual PowerShell that we're calling back to something really simple again. So we're basically back to the start where we have our original sort of rather uninteresting output. But what's interesting is that so far, every time we've run PowerShell, we've been using the standard default PowerShell create method. Turns out there are some overloads of this, and they all, you know, work slightly differently. But one interesting one is run space mode. So by default, when we create PowerShell with the empty overload of this, what actually happens is when it comes to invoke time, PowerShell tries to work, this PowerShell object works out if it has a run space to run on or not, and if not, it'll create its own. and it thinks of itself as owning that run space. And so at invoke time before it invokes, before it runs, it will create this run space object, open it, run the command, output the results, and then when we dispose of the PowerShell object, it will also close and dispose of that run space. This is one of the reasons why it's really important to make sure you always dispose of the PowerShell object. But one of the easiest overloads here is with this run space mode enum. It has two values. There's new run space, which turns out is essentially the default version of this. It's just more explicit. And you won't see any change in the output. It runs just the same. And in fact, as we sort of work through this, we're not going to see much change in the output here, but it might be important for more sophisticated commands. This tells PowerShell, okay, always create and open a new run space. But the other one is much more interesting. It's runspace mode.current run space. And when we try to run things this time, we're going to see something kind of weird, which is that we get an exception. And it says, we can't use the current run space because there is no current run space. You know, you idiot, what are you doing? So usually this is really useful when you're running from something like the end processing method in a commandlet. If you're running in .NET code on a thread that already is running with a run space in it, then using this means that you can reuse that run space and you can use any of the definitions available in it. You can manipulate it, change it. You can hook back into that run space from your .NET code and run arbitrary PowerShell in it. If we want to use it here, then we have to explicitly create that thread. Sorry, that run space, that local run space. So run spaces in PowerShell, threads are often associated with run spaces, which is to say that not every run space belongs to a thread, but in general, if PowerShell isn't given a run space like explicitly, it'll look on the current thread, and it'll look for this property. It looks like a static run space.default run space, but it's actually a thread local static, which means that on a different thread it could have a different value. So we can explicitly create our own by assigning to it, and then we have to make sure that we open this run space. And now when we say use current run space, things start working again. So this is kind of like a lot of work to go through just to, you know, get the same result. And in this case, yeah, there's no really good reason to use this. This is usually for reusing something that you already, a run space that's already defined for the current thread. Usually because you're running underneath something like a commandlet. So more likely what you want to do is create your own run space. So you can do that pretty much the same as we just did. It's just that rather than assigning it to a static, which, you know, would then feasibly be reused by anything else running on this thread later, it's kind of like our own special run space. And you can provide that as input to the create method here. It's one of the overloads, but generally I think the right way to do it is actually to assign it here, because you can see that run space and run space pool kind of have a symmetry over that. And so we say, okay, well, let's just assign our run space. And now we can run things as usual. The big difference is that, say we wanted to reuse this run space later, it wouldn't be destroyed by disposing of this PowerShell. Okay, so before we do something like talk about using run space pools, I think it's worth looking at running PowerShell off of the current thread, so not running it synchronously. And in particular, we can use the invoke async API. This is available from PowerShell 7. There's a way to use the begin invoke and end invoke methods if you're writing against Windows PowerShell 5.1 or against PowerShell Standard. And .NET provides convenience methods to convert it back to a task returning method instead. But since this exists in PowerShell 7, I'm just going to use it directly. Now, by default, the return type of this is actually a task of a PS data collection. So let's have a look at that. This isn't really a huge departure for us so far. We're just going to take this task and get its result. And we should see that when we run this, we get exactly the same output as we are used to getting. And all that's really happened is that we've kicked off PowerShell running on a different thread, and we can then get the results here. So a better illustration of like a proof of that is that we can say sort of sleep 2, and then we can say console write line running PowerShell. And now when we run our script, we immediately see we're running PowerShell, but then it takes 2 more seconds before we get output. And in fact, if we sort of say we define the script to have some kind of output, then we'll see that we say we're running PowerShell, we wait 2 seconds, and then we see the output reported. Okay, well, there's kind of more here. This PS data collection type is a bit conspicuous, and it's interesting to think, okay, why is this important here? What's the meaning of this type in this object? Well, it turns out that we can find our own collection here. And we can provide that collection to be used by PowerShell in its asynchronous invocation. When you do this, you kind of want to ignore the output at this point. This is now going to just be an ordinary task. And your main interest is in the contents of this output collection. So we've now replaced the actual result of the PowerShell invocation with the contents of our data collection that we created ourselves. And what we're going to do is we're going to kick PowerShell off, then we're going to wait for it to finish, and then once it's finished, we're going to look at the collection to see what's in it. And we get exactly the same result that we had before. What's really interesting about this is that this type actually defines events. So, for example, you can say, okay, well, as things are added to this collection, I want to know in real time or like, concurrently what's being added. So we can say something like output index. It's kind of a strange interface, but that's how it works. And when we run it again, we can see, okay, we're running PowerShell, we sleep for 2, and then as these things are added, we see them added to the collection. And then as we, and then they're printed at the end because they're in the collection still. Now, this seems like a slightly strange thing to do, but imagine when you run PowerShell in the console, if you have something like 1, 2, 3, sleep 2, and then you press Control-C, you expect that, in fact, let's try it. You expect that, based anyway, myself, 1, 2, 3, sleep 2, you expect to be able to cancel that with Control-C, but you still get partial output. Well, the equivalent of cancellation with the PowerShell API is something like Okay, let's do thread.sleep 1 second, and then we'll say PowerShell.stop. Now this stop method is going to cancel whatever is running at this point, which is probably going to be, well, is going to be this script. And so let's see what happens when we run this program. So we've added these things to the collection, but then we throw a pipeline stopped exception. So imagine we didn't have this PS data collection. We got rid of all this. We went back to the original invoke async and we stopped PowerShell. Even though we would have had some partial output, we would have thrown a pipeline stopped exception and we wouldn't have been able to collect or use any of that output. But when we manage PowerShell ourselves, when we manage the output collection ourselves, we're perfectly able to catch this pipeline stopped exception. And when we run our application this time, we get to keep our partial output. Okay, so this is like a fairly cute example, right? What about something more interesting? What about a more interesting application of the PowerShell API? Let's look at writing a service that runs PowerShell asynchronously. And I'm going to show you a few tricks here. So first of all, I've kind of set up some boilerplate here. You know, there's some stuff behind the scenes where we run we have this PowerShell service thing, and it's going to get picked up by something I wrote earlier. But we have to obey this create int max run spaces. The reason I've done that is because I want to show you a run space pool. So let's, for example, use, let's create a run space pool with the run space factory port create run space pool. And then you can see that in the overloads, there's a min run spaces and we've defined max run spaces. And then we're going to want to create a PowerShell service around this run space pool. So let's set up our PowerShell service object with its constructor here a little bit. So now we have sort of this PowerShell service with a run space pool, but we need to work out how we're going to actually execute PowerShell asynchronously. Well, the first thing is this returns a task, and we're going to want to be as asynchronous as possible. So this method shouldn't block for anything. And so that means that when we were going to use a using statement like this before, we can't actually do that anymore because we'd need to block in order for the disposer to wait. So we're going to have to solve that problem a little bit better in the future. But for now, let's just say that, okay, we're going to return PowerShell dot add script, and we're going to add a script to it. Oh, we're going to say var PowerShell equals PowerShell dot create. We're going to add our run space pool to it, and we're going to return PowerShell dot add script, and then we're going to call invoke async. So the first problem we have is that invoke async returns the wrong type. And it's not really easy using this invoke async method to return the right type. So instead, we're going to use continue with, which is a task concept, but which lets us do some things after the task, after the actual PowerShell invocation has finished. So the first thing we can do, well, okay, I've jumped ahead a little bit. One thing that you might notice here is I'm saying I'm going to return a string. And that's kind of weird. Like, don't we want full PowerShell objects? Well, to come clean with you, I'm designing this to be like a web service, and I just want it to return a PowerShell, like the string of the PowerShell output that I would expect. And there's a really simple way to do this. I can pipe the output of my script to outstring. And what outstring does is it calls, if you've never worked with it in the formatter, in the console, is it'll actually run the PowerShell formatter on the objects that it receives and then gives them to you as a string rather than printing them. So, for example, GCI to outstring is going to give me the normal looking output, but it's actually one big string. So I can say, it's just a giant string that doesn't actually give you there's no objects underneath it. It's been rendered into a string rather than into the console. But in this case, that's kind of what we want, because we want to return a string over our service request. So when we continue, right, let's continue with, the PowerShell processing task is now done. So the riddle of how do we dispose of PowerShell is now kind of easy to set up. We can say, okay, PowerShell dispose is the first thing that we should do, because our object is now complete. Our object is now done being used, and we don't need to, and so this is the best possible time we can dispose of it. The next thing we should do is we need to transform what we got back, which is going to be a set of strings in PowerShell, a collection of strings, into one string to transform back. So let's use a little string builder. And we're going to look through the result that we get in pstask.get result. And we're going to append each component of the results that we get. And here, because of the way the async API works, we're kind of forced to call this base object, do it the hard way rather than getting a nice generic result. But we're able to cobble it together, and now we have a nice string. So this looks sort of vaguely like it's going to work. I actually have this set up to some degree. So let's see what happens. Okay, running a server. Need a new terminal. And we're going to say invoke REST method, UP, localhost, what is it, 5,000, script equals get child item. Oh, not found. Oh, that's right, because I didn't actually specify that we're running under PS. Uh-oh. Haha, yes, we forgot to open our run space pool. This is why a create method's important, is because it does something that isn't just a factory operation. It actually needs to open a run space, which is something that you wouldn't want to do in a constructor. You need to be able to do, because this is going to alter state in some way by opening a run space, you want a factory method to do it. Okay, let's restart our service. Service running, increase the size of that a bit. Now we run this, And look, we get a nice string output. But we have a problem. What if somebody's malicious and tries to send us a really long running script? This is going to sit there for 10 seconds. So it would be really nice if we could do something like define a timeout. One way to do that is with a cancellation token source. And so we create a cancellation token source, and we should make sure that we dispose of that as well after we're done. What we want to do is, okay, first of all, let's set up a default timeout. So like cancel after 2 seconds. 2 seconds is a pretty long time for a web request. We don't really want it to go on further than that. And then we're going to want to say, okay, for this cancellation token source, for its associated cancellation token, we want to register something to happen when it's canceled. We're going to put that down here. What do we want to happen when we cancel this token source? Well, we're going to call PowerShell.stop, and that's going to cancel our PowerShell execution. Just make sure that things are plumbed through properly. We're going to say, okay, if we get a pipeline stopped exception, which is what happens in the example where this task is, where we call PowerShell.stop on this task, we're going to throw a new operation cancelled exception. Need another L. Needed the one L. There we are. And we'll say script timed out with wrapped. Okay, so now we've linked our cancellation token. We've actually, ASP.NET provides, or our caller provides a way for us to send a cancellation token in. We also define a default timeout because it's going to be easier for me to demonstrate. The crucial part is that we register the cancellation callback for that cancellation token to tell PowerShell to stop. And then when if PowerShell is stopped and throws a pipeline stopped exception, we have to make sure we translate into an operation cancelled exception. So let's restart our server. And back in our original terminal, we can see that if we run GCI, we get the good old same string we always got. But if we say sleep 10, well, time's ticking away. Oh, it says that we timed out because now we have this ability to manage pipeline stopped exception. And what's kind of interesting about this is that, okay, well, that's great. And we also ran we're also using a run space pool, which means that we can kind of run all of these concurrently, and they'll all fail. But the nice part is that because we have as many as 10 run spaces operating at the same time, sorry, I didn't tell you that, but let's say max run spaces is set to 10, we can, rather than having to wait 2 seconds, times 5 is 10 seconds, we can see that in this case, we basically immediately got, within 2 seconds or so, we got results for all of them. And that's because using a run space pool, we get a sort of concurrency of up to max run spaces. Anyway, so hopefully this is sort of educational about how to actually use the PowerShell API to do something relatively sophisticated. If you're curious about what's actually happening here, I'm actually using an ASP.NET web server. You might have recognized that in the server output here. And when we run invoke REST method, it goes and executes the PowerShell script on the web server, which is a terrible idea. Don't ever do this. You know, there are professionally hosted versions of this, like the Azure Functions PowerShell worker. This is just something awful that when you invoke it, it runs PowerShell on the server and then gives you the formatted output back. But hopefully that's kind of educational about, how far you can really go with the PowerShell API. And you'll notice that we didn't spend that many lines on this. This is sort of like 40 lines of code, more or less. And half of it is dealing with things like this cancellation stuff. So that brings us to the end of the talk. Hopefully, especially with that last example, you can appreciate that the PowerShell API is quite capable. It's capable of doing, quite sophisticated things. And in fact, if you're trying to run PowerShell, especially in a way like we were in that last example as a service, there's not really another way to do it. There are a couple of small ways, but PowerShell API is by far the easiest. And it makes it relatively straightforward to it doesn't get wildly complex as your scenario gets more complex. Even in our last example, this still wasn't like the number of places where we're touching PowerShell doesn't really get too difficult. If if this talk sort of like raised a lot of questions for you, or if I went over anything too quickly, or if you wanted more detail on any of it, then you can find this talk and the associated code and actually a much larger document that I wrote around this material at this link. But eventually it'll be, somewhere that PowerShell owns and it's more official. This is just where it lives while I've been writing this talk. So yeah, hopefully you enjoyed that. Hopefully this has been informative, and hopefully you feel a lot more confident and able to use the PowerShell API in your own code that you write after watching this. Thank you.